You wake up. For 1 second, the dream is still there. Vivid whole. Complete. By the time you reach for your phone, it's already gone. It feels like a glitch. Something broken in your own mind. But the real answer is far stranger than a glitch. And it starts with a question most people never think to ask. Why does your brain build an entire world every single night, full of people, places, impossible physics, entire storylines, only to delete almost all of it within minutes of you waking up? You didn't imagine that dream weekly. Your brain built it in full detail. The forgetting is not an accident. Start with the basic biology. Most dreaming happens during a stage of sleep called REM, short for rapid eye movement, named for the way your eyes dart back and forth beneath closed eyelids while your brain runs its nightly simulation. Neuroscientist Matthew Walker, who has spent decades studying sleep at the University of California, Berkeley, describes REM sleep as a state where the brain is almost as active as it is while you're awake, sometimes more active in certain regions, even though the body lies almost completely paralyzed. Almost completely paralyzed. Think about that for a second. Your brain deliberately shuts down the connection between your motor cortex and your muscles during REM sleep, a state researchers call REM autonia. Without it, you would physically act out whatever your dreaming brain invents. Some people, due to rare disorders, lose this paralysis entirely, and doctors have documented them literally throwing punches, running, even attacking furniture while still fully asleep, acting out the exact content of their dream in real time. Your brain is not being lazy when you dream. It's running something closer to a full simulation, with your body's safety switch deliberately flipped off. This paralysis system is so precise that it can fail in isolated, almost surgical ways. Some people experience what's called sleep paralysis, waking up while the autonia is still active, fully conscious, but temporarily unable to move a single muscle, often accompanied by vivid, sometimes terrifying hallucinations layered directly onto the waking room around them. Researchers studying this phenomenon describe it as a kind of overlap glitch, two brain states bleeding into each other for a few disorienting seconds before fully separating. It's a strange reminder of just how deliberately engineered this nightly shutdown really is, and how strange things get on the rare occasions it misfires. So if the simulation is this vivid, this active, why does almost none of it survive until morning? The answer lives in a small brain structure called the hippocampus, and one of the strangest details in all of neuroscience. Memory researcher Robert Stickgold at Harvard Medical School has spent years studying exactly this question. His work points to a chemical culprit hiding in plain sight. Norepinephrine, a neurotransmitter your brain relies on heavily for laying down new memories while you're awake, drops to some of its lowest levels of the entire day during REM sleep. Without enough norepinephrine circulating, the hippocampus struggles to properly encode what's happening into long-term memory, even while the experience itself is unfolding in vivid detail. You are, quite literally, living through an experience your brain has almost no ability to save. This raises an obvious question. Why would evolution build a system this wasteful? A brain that generates rich, complex nightly experiences, then deliberately cripples its own ability to remember them? The leading answer reframes the entire problem. Dreaming may never have been designed to be remembered at all. Memory may just be an accidental side effect of a much older, much more essential process. Psychiatrist J. Allen Hobson, whose work fundamentally reshaped how scientists think about dreaming, argued that REM sleep serves as a kind of overnight maintenance mode for the brain, a period when neural circuits are activated, tested, and reorganized without any real-world stimulus interfering. Under this view, the images and stories you experience while dreaming are closer to a byproduct than the main event, a bit like the noise a machine makes while it's doing its actual job in the next room. Other researchers have pushed this idea even further into evolutionary territory. Finnish cognitive scientist Antti Rauvansvuo proposed what's known as the threat simulation theory. His research suggests that dreaming may have evolved specifically as a kind of nighttime rehearsal system, one that allowed ancient humans to safely simulate dangerous scenarios, being chased, being attacked, falling from a height, all without any of the real physical risk. Picture an early human sleeping in a shelter, generations before written language, generations before permanent settlements. A dream where a predator suddenly appears from the treeline isn't just a random story. It's practice, a chance for the brain to rehearse a threat response with zero actual danger involved, sharpening the exact reflexes that might matter the very next day. Under this theory, remembering the dream in perfect detail was never really the point. Living through it, and quietly updating your threat responses in the background, was the entire function. Forgetting it afterward may simply be a leftover side effect of a system built for rehearsal, not for storytelling. Revanchuo's research draws on a striking pattern across cultures and age groups. Studies analyzing thousands of dream reports have consistently found that threatening content, being chased, falling, confronted, appears far more often in dreams than pleasant or neutral scenarios would predict by chance alone. Children, whose waking lives are statistically far more dangerous across human history than adults' lives, tend to report an even higher proportion of threat-based dreams than adults do. This pattern is difficult to explain if dreaming exists purely as random noise. It becomes much easier to explain if dreaming exists, at least in part, as a rehearsal system that evolution simply never bothered to turn off, even now that the modern world has made most of these ancient threats obsolete. There is another layer to this that most people never hear about. Sleep researcher Rosalind Cartwright, who spent much of her career studying the emotional function of dreams at Rush University, found that dreaming appears to play a critical role in emotional processing. Her research, including studies following people through divorce and major life stress, suggested that dreaming helps the brain work through difficult emotional material overnight, sometimes even reducing depression symptoms in people who dreamed more actively about their stressful waking experiences. This reframes what a dream might actually be. Not simply a random story your brain tells itself for entertainment, but closer to an overnight emotional processing session, one that doesn't require a permanent transcript to still be doing real work. You don't remember most therapy sessions word for word either. That doesn't mean they didn't do anything. So why do you remember any dreams at all, even the occasional one? Timing turns out to matter enormously. Most people who recall a dream do so because they happen to wake up directly out of REM sleep, catching the tail end of that vivid brain activity before the natural forgetting process could fully take hold. Wake up an hour later, deep in a different sleep stage, and that same dream, no matter how vivid it felt in the moment, is often already gone completely. This explains something almost everyone has experienced firsthand. A dream feels completely real and unforgettable in the half-second after waking. Then, within minutes, sometimes seconds, it dissolves, like trying to hold water in an open hand. Stickgold's research suggests this isn't random bad luck. It's the natural window closing. The hippocampus briefly has a chance to grab fragments of the experience right as you surface from REM sleep, and if nothing interrupts that narrow window, some of it survives. Get distracted by an alarm, a phone screen, the pressure of getting up immediately, and the fragments that hadn't been secured yet are simply gone. There's a strange practical implication buried in all of this. People who deliberately train themselves to lie still for even a few seconds after waking, resisting the urge to immediately check a phone or jump out of bed, often report remembering significantly more of their dreams over time. Not because they're doing anything mystical. They're simply giving that brief hippocampal window slightly longer to work before the moment passes. Now here is where the story takes its counterintuitive turn. Modern life has quietly made dream forgetting even more efficient than it already was. Alarm clocks yank you out of sleep at a fixed time, often mid-REM cycle, rather than allowing your body to surface naturally the way it would have for nearly all of human history before mechanical timekeeping existed. The abrupt jolt of an alarm interrupts the exact narrow window your hippocampus needs to catch even fragments of the dream. Add the immediate flood of a bright phone screen the moment your eyes open, and you're essentially slamming the door on memory formation before it even has a chance to begin. For nearly the entirety of human history, waking happened gradually, with first light, with natural body rhythms, with no artificial disruption at the exact fragile moment memory needed just a little more time. Your ancestors likely remembered more of their dreams than you do, not because their brains worked differently, but because nothing was rushing them out of that final, fragile window each morning. There is something almost poetic in this. The same evolutionary system that once rehearsed danger by firelight, sharpening reflexes no one would ever consciously remember training, now gets interrupted every single morning by a machine built specifically to interrupt it. You are not forgetting your dreams because something is wrong with you. You are forgetting them because your brain was never built to keep them in the first place, and modern mornings have only made that forgetting faster and more complete. Consider what this actually means about the relationship between experience and memory. You tend to assume that anything worth living through is worth remembering, that forgetting automatically means failure or loss. Dreaming quietly breaks that assumption every single night. It suggests an experience can be complete, valuable, even necessary, without ever needing to leave a single trace behind. The rehearsal happens. The emotional processing happens. The nightly maintenance happens. None of it needs a witness, not even the one person who technically lived through it. Somewhere behind your closed eyes tonight, your brain will build an entire world again, full of impossible physics, invented faces, entire storylines that will never exist anywhere else. It will feel, for a moment, more real than anything in your waking life. And then, exactly as designed, it will let almost all of it go. You wake up. For 1 second, the dream is still there. But that fading world was never meant to last until morning. It was only ever meant to do its work quietly, in the dark, long before you were ever going to remember it at all.